Hello and welcome to my channel. In this video we will learn introduction and conditional probability of chapter 13 probability in 11th in 12th class math. So we are starting this chapter, that is the probability. Now we have studied the probability in the 11th standard also, okay, and there we have seen the definition of probability. Then we have seen also how to calculate the probability of event of a sample space of random variable, okay, and we have studied the axiomatic approach of probability, then the classical theory of probability, okay. Now here in this chapter we will learn about the conditional probability, okay, first of all. So let us now look at what is probability and see the definition of probability in 11th class math that we have studied. So probability is the chance of occurrence of an event of a sample space, okay, of a random experiment. So let us recall that probability is the chance of occurrence of an event of a sample space of a random experiment. Okay, this is the definition that we have studied in 11th class. Now let us look at the formula that we have studied in 11th class, okay. So let E be any event of a sample space of a random experiment. Okay, then the probability of E, we denote probability of E in this way: P bracket E was equal to number of elements in the set E divided by number of elements in the sample space, okay. So this formula we have studied in the 11th class. Alright, so this much you have to know to understand further what I will explain, okay. So let us now look at what is conditional probability, okay. So conditional probability now let us take one random experiment, okay. So consider a random experiment of tossing a fair coin, okay. That means it is not biased coin, so it is a fair coin 3 times, okay. So consider a random experiment of tossing a fair coin 3 times. Now if you look at the sample space, it will be, so you can get H in the first toss, H in the second toss, H in the third toss, or you can get H in the first toss, T in the second toss, H in the third toss. Then you can get H in the first toss, H in the second toss, and T in the third toss. So like this we will write all the possible outcomes here. So also you can get H T T, right? Then you can get T T T, then T H T, then T T H, and T H H, okay. So altogether there are 8 outcomes of this sample space, right? Now we will consider 2 events here, okay. So let E be the event uh, event of getting at least 2 heads, okay, and F the event of getting tail in the first toss, okay, tail in the first toss, okay. So that is, if you write the event E, that is nothing but, see, the event is what? The event of getting at least 2 heads. So that means H will be there because it contains 3 heads, right? Then HTH will be there because it contains exactly 2 heads. Then HT will be there, right? And then THH, right? This is the event T. Now if you write event F in terms of set notation, it will be what? See, the event F is event of getting tail in the first toss. So that means TTT will be there because tail is there in the first toss here. Then THT, right? Then TTH and then THH, right? So now if you calculate the probability of E, that will be what? So if you calculate the probability of E, the formula that we recalled, by that formula what we will get? Number of elements in set E divided by number of elements in set S. So that is nothing but, so number of elements in set E is 4, right, and number of elements in the sample space are 8, so half you will get here, right. Then if you find the probability of F, what you will get? Number of elements in the set F divided by number of elements in set S. So number of elements of F are what? 4, and number of elements of sample space are 8, so this will give you half, right. This we have seen in the 11th class, right. Now we will consider one more situation now, okay. So suppose we take that the event F is already occurred, okay. So listen carefully, we have to take that event F has already occurred, and now we can raise the question that what is the probability that the event E will occur such that F has already occurred, okay. So this we have to see now. So consider, or we can suppose, okay, suppose the event F has already occurred, then what is the probability of occurrence of event E, okay. What is the probability of occurrence of event T? Okay, we can also write this such that event F has occurred, okay. So now what we have to find is this. So probability that E occurs such that F has already occurred, right. So now what will happen is, now since we have to take that F has already occurred, now our new sample space will be F. So instead of S, now our new sample space will be F because this event has already occurred, okay. So we can write here the here the sample space will be F instead of S. Okay, so now the probability that E occurs such that F has already occurred. Okay, what will be this? It will be probability. So now we have to take the sample points which are common to both E and F, because now our sample space is nothing but F, right? So this is our sample space, or we can also write this number of elements of F right here. So probability of E such that F has already occurred will be the new denominator will be number of elements in F, because our sample space has changed here, right? So now we have to also take the elements which are common to both E and F, because we are not taking elements which are common to E and sample space. Okay, we are taking elements which are common to E and the new sample space, which is F. So here the number of elements of F should not be equal to 0, otherwise we won't get the denominator here. So now what we will do is we will divide by number of elements of sample space, right? So probability of E such that F has occurred will be equal to number of elements in E intersection F divided by number of elements in the sample space divided by number of elements in the sample in the set F divided by number of elements in the sample space. Just we are dividing and multiplying by number of elements of S, okay, for in this quotient. Okay, so this will be equal to what? Now if we look at this, it is nothing but probability of E intersection F divided by, if you look at this number of elements of F divided by number of elements of S, it is probability of F. And so what we get is probability of E such that F has already occurred is equal to P E intersection F divided by P of F. Okay, so this is the formula. Now let us formally define what is the conditional probability. So definition: so we can start like this. So if E and F are any two events of the sample space S of a random experiment, then the probability of occurrence of E such that F has occurred. So that is, we denote it by PE such that F has occurred is given by this probability of E such that F has occurred is equal to probability of E intersection F divided by P of F, and such that P of F, probability of F is not equal to 0, otherwise we will get not defined quantity here. Okay, so this is the definition. Now let us look at some properties related to the conditional probability. Okay, so property number 1, let us see. So this is the property here. So P sample space such that F has already occurred is equal to probability of F such that F has occurred, which is equal to 1. Okay, So let us look at the proof of this. So now what we will do is we will look at this first. So probability of sample space such that f has occurred will be by definition probability S intersection f, right, divided by probability of f by definition of conditional probability. So this will be equal to probability of, now sample space intersection any event is the event itself, right. So probability of f will get divided by probability of f, so which is equal to 1. Okay, and if you look at this probability of f such that f has occurred, then again by definition probability of f intersection f divided by probability of f, which is equal to probability of f divided by probability of f. So this is equal to 1, right. So both of them are equal to 1. So therefore probability of S such that f has occurred is equal to probability of f such that f has occurred equal to 1, right. So this is the proof. Now let us look at the next property, property number 2. Okay, so let us take two events. If A and B are any two events, okay, of sample space S, okay, and F is any event of S such that probability of f is not equal to 0, then we have this probability A union B such that f occurs is equal to probability of A such that f occurs, okay, plus probability of B such that f occurs minus probability of A intersection B such that f occurs. This is the formula, and in particular, so if in particular A and B are disjoint, let us see what is the formula we get. In particular, if A and B are disjoint, then we get this probability of A union B such that f occurs is equal to probability of A such that f occurs plus probability of B such that f occurs. Okay, this is the property number 2. Let us prove this. Proof. What we have to do is we have to look at this first, LHS. Okay, let us look at the LHS. So probability of A union B such that f occurs, okay, f has occurred. Now this can be written by the definition as probability A union B, right. The brackets are important here, so this is actually like this. Okay, so probability of A union B intersection f divided by probability of f. Okay, so this will be equal to, now by distribution of union over intersection, what we will get is probability of A intersection f union B intersection f and then divided by p of f. Okay, so this is by distributivity or distributive property of union. Okay, let us write it properly, of union over intersection of sets. Okay, then this will be equal to, now we can use the set formula here. So that is for probability, set formula for probability. So that means you will get probability of this first set A intersection F plus probability of this second set B intersection F and minus probability the intersection of these two sets. So that is nothing but A intersection F intersection B intersection F. Okay, and then this is divided by P of F. Alright, so this will be equal to what? Now we can divide this denominator for all the three terms. So probability of A intersection F divided by P of F plus P B intersection F divided by P of F minus probability of A intersection F intersection B intersection F divided by P of F. Okay, so what you will get is this is equal to, now if you look at this is definition for P A such that F has occurred. Okay, so probability A such that F has occurred plus this is probability of B such that F has occurred, probability of B such that F has occurred minus, now if you look at this we can write this as what? So probability A, right, all the operations of sets are intersection here, you can see. So A intersection B intersection F we can write. Okay, the order is not important, A intersection B intersection F and then divided by okay, we have this divided by P of F. So this is equal to P A such that F has occurred plus P B such that F has occurred minus probability. So if you look at this, if you put brackets like this here, so it is probability A intersection B such that F has occurred. Okay, so what we get is probability of A union B such that F has occurred is this here, and this is what we wanted, right? So this is the formula. Okay, now in particular if A and B are disjoint, what will happen? So if A and B are disjoint, so that means what? A intersection B is empty set, right? So this implies probability of A intersection B is 0. Okay, and that means probability of, so if we divide by this F on both sides, so P A intersection B divided by P F equal to 0 divided by P F, so which is 0 actually. So this implies this is probability of A intersection B such that F has occurred is equal to 0, right? So if you call this as 1, so from 1 what you will get? from one PA union B such that F has occurred is equal to PA such that F has occurred plus PB such that F has occurred minus 0. This will be 0, right? So we will get this formula. Okay, that this is what we wanted. Now let us go to the next property, property 3. So property 3 is probability E complement such that F has occurred is equal to 1 minus probability of E such that F has occurred. Okay, where E and F are any two events of sample space S, okay, and such that probability of F is not equal to 0. Okay, also this we will take probability of F is not equal to 0. So let us look at the proof. So probability of E complement F we have to find. So for this what we will do is we will consider this probability of S such that F has occurred is what is 1. We have seen this by property number 1. Okay, we have seen this in property number 1 here. Now this implies we can write this as, so S can be written as E union E complement, okay, such that F has occurred. This is already there here, equal to 1. Now why we can write this? Because any set union its complement gives us the whole sample space, right? So if you look at the sample space here, so if you take the set E like this, and this is the complement, so if you take the union, that means you are getting the whole sample space S, right? So therefore we get this, and then now we can use the property number 2. So property number 2 says what? So probability E such that F has already occurred plus probability E complement such that F has already occurred minus probability of E intersection E complement such that F has occurred, right? So this equal to 1. So probability of E such that F has occurred plus probability of E prime or complement such that F has occurred is equal to, I mean, minus 0, because this is equal to 0, right? Because E and E prime are disjoint, since E and E prime are disjoint. So this implies probability of E such that F has already occurred plus PE complement such that F has occurred is equal to 1, right? So this implies probability of E complement such that F has occurred is equal to minus 1 minus probability of E such that F has already occurred. Okay, so this is the formula that we wanted, right? So this much concept you have to know to solve the exercise 13.1. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.